Every day, we are exposed to bacteria, viruses, fungi, and other foreign substances. Yet, we don't constantly get sick. Do you guys wonder why? This is because our immune system is always active in detecting, responding, and remembering this pathogen. Remember that our immune system is divided into two major parts, which are the innate immune system that responds immediately and broadly, and the adaptive immune system which responds specifically and creates memory. These systems are different but they work together to defend our body from any infections. So now, let's begin with the system that always acts first, and this is the innate immune system, the body's first defense. The innate immune system is present from birth and does not need prior exposure to a pathogen to respond. It functions through barriers, cells, and proteins. In innate immunity, we have the physical and chemical barriers. Our body's first protection is always structural, as the skin acts as a physical barrier, preventing microbes from entering. Mucosal surfaces are those in the respiratory and digestive tracts. They are lined with epithelial cells and held together by tight junctions. These surfaces also produce protective substances that trap microbes, while the acid in our stomach destroys many pathogens. Another example is tears and saliva, as they contain enzymes that break down bacteria. Did you know that even our urine helps in flushing the microbes out by using our urinary tract? Even the normal microbiota acts as a defense by competing with harmful organisms for space and nutrients. Cellular defenses are then activated once these microbes pass these barriers, and then the immune cells will respond. They are known as phagocytes and they have different types. These are the neutrophils and macrophages and the natural killer cells. Neutrophils and macrophages are known to be the primary phagocytes. They engulf pathogens through phagocytosis, internalize them, and destroy them by using lysosomal enzymes. The macrophages are highly adaptable. They can be classified into two. First, the M1 macrophages that promotes inflammation and microbial killing, and the second one is the M2 macrophages that support tissue repair and the resolution of inflammation. Natural killer cells or NK cells target virus-infected and abnormal cells and they release perforin. This will then form pores in target cell membranes and granzymes. This will then trigger apoptosis, which we all know as cell death. The innate immune system also includes circulating proteins that are known as the complement system. These proteins will then be activated in a cascade through classical, lectin, or alternative pathways. When infection occurs, inflammation begins and this is when our immune cells release cytokines. These cytokines will start to dilate the blood vessels, increase permeability, and recruit more immune cells. This will then produce redness, swelling, warmth, and sometimes fever. Innate immunity is fast and effective, however, it still lacks specificity and memory. If the same pathogen invades again, the response will be the same. And now, this is where the role of adaptive immunity comes in. Adaptive immunity is known for its precision and memory. It takes longer to activate because it must first recognize the specific pathogen involved. However, once it is activated, it is highly precise and capable of doing memory. It consists primarily of the T cells and the B cells. The T cells will then mature in the thymus and express unique T cell receptors. There are three major types of T cells. First, the CD4 helper T cells that will coordinate immune responses by releasing cytokines and activate other immune cells. CD8 or cytotoxic T cells will directly kill infected cells using perforin and granzymes. And lastly, the regulatory T cells that maintain immune tolerance and prevent excessive immune reactions. For these T cells to be activated, it requires three signals. First, the recognition of a peptide antigen that is presented on MHC molecules. Then, there needs to be a costimulatory interaction such as the CD28 binding to the CD80 or CD86. Lastly, there needs to be a cytokine signaling that directs differentiation. The B cells originate in the bone marrow and recognize antigen by using their B cell receptors. When activated, It works with CD4 T helper cells. Our B cells also differentiate into plasma cells, which will then produce our antibodies. These antibodies can neutralize pathogen directly. It prevents them from infecting host cells and can also promote opsonization. This will then make the microbes easier for phagocytes to recognize and destroy. Another function of our antibody is to activate our complement system and enhance pathogen elimination and mediate the antibody-dependent cellular cytotoxicity. The B cells and T cells also explain the foundation of how vaccination works. It is when the B cells and T cells are activated during an immune response, and some of them differentiate into memory cells that persist in the body for long periods. If the same pathogen enters the body again, these memory cells enable a faster and stronger immune response. There is a communication between the two immunity systems. Our innate and adaptive immune systems are constantly working together to defend the body. Dendritic cells act as a bridge between the two systems as they capture pathogens using innate receptors. It will process them and present antigens to naive T cells in the lymph nodes, and signals or cytokines from innate cells will then guide T helper cells to differentiate into specific types depending on the threat. At the same time, adaptive cells can then enhance innate responses. Our immune system works like a team rather than a single reaction. For every threat that comes into our body, innate immunity jumps in immediately with a broad defense, while adaptive immunity takes a little time but attacks precisely and remembers the threat for the future. Together, they spot, attack, and remember invaders. The next time a pathogen shows up, your body is ready to respond faster and stronger. To make it easier to remember how these two systems work, here is a quick comparison table. And that is all for our innate versus adaptive immunity.